When we think of a chemical reaction, we think of a reaction that produces a lot of heat, a lot of energy, and sometimes an explosion. However, a lot of reactions aren't like this. Luminescent reactions aren't like this. Specifically, a chemiluminescent reaction, where you can mix two chemicals to produce a bright blue light, isn't like that. A photoluminescent reaction, where you've got watch dials that are able to glow in the dark, as well as toys that are able to glow in the dark, aren't like that. Bioluminescent reactions, where you have jellyfish that produce lights in the deep sea, aren't like that. And sonoluminescence, where a bubble, which is vibrated by sound and produces a lot of light inside a jar, isn't like that. All of these don't produce much energy, and they all produce light.
Chemiluminescence is the emission of light by a substance without producing heat. Unlike incandescence, where light is emitted as a result of heating, it is a form of cold radiation. Jellyfish, glow sticks, and fireflies are all examples of chemiluminescence. Another great example of chemiluminescence is the use of luminol. Luminol reacts with different chemicals including bleach and hemoglobin to produce chemiluminescence. Because luminol reacts with hemoglobin, crime scene investigators will spray a suspicious area, turn out all the lights, and block the windows, and look for a bluish-green light. If there are any blood traces in the area, they will glow. A drawback of using luminol in crime scenes is that bleach also reacts with luminol to produce light. This leads to false positives when trying to detect blood.
In this experiment, we're going to demonstrate the reaction between bleach dissolved in water and luminol and sodium hydroxide dissolved in water. This reaction produces chemiluminescence, or cold light, which is a chemical reaction without heat that still produces light. The luminol will be oxidized, and a light will be produced.
For the experiment, we created two solutions. Solution A consisted of 10 milliliters of bleach and 90 milliliters of water. Solution B consisted of 0.04 grams of luminol, 0.4 grams of sodium hydroxide, and 100 grams of water. Then we placed the two solutions in ice. The cold temperature makes the reaction last longer because most chemical reactions are dependent on temperature. Then we mixed the two solutions together to create a chemiluminescent reaction. In the reaction, luminol is oxidized by the bleach to the aminophthalate ion, which is produced in an electronic excited state. This gives out energy as light when it decays to the ground state.
And paste and did the...
Yeah.
Okay. Lights are just going to go off for a few seconds.
Shoot, I can't see.
Together.
Oh, so cool. You messed it up. Jack. Keep going. More.